I got it blue enough. Okay, now that I got that going, let me make sure it is going. Oh, there it is. Oh, there we go. We're going. Now the question is, do I even need the projector? Because if I was just going to address this one issue, then the computer on the screen is useless. And actually, it's kind of a distraction, so let me turn it off. It'll still be going here. So, now there's a section right here, about right here, about right there, that doesn't come through. Oh, I always miss it. It's like right here. To right there. It gets clipped off of the stream. Oh my, that's almost perfect. It's about right here. I can't right there. I know. Oh, yep, that's it. Okay, so let's just imagine. Okay, so to address this issue, well, imagine we have a vector velocity v, which is, I'll just make it up and say it's 4 by 3. So you can represent v as 4I plus 3j. Or maybe I should, here, I'll address it a different way. I don't want to confuse the issue, so what I'll do, here's what I'll do. I'll do it this way. Okay, now, u r u theta, and now I've got a vector which is a v that looks longer than that, so I'll say it's 4 ur plus 3 u theta equals to what I plus what j. So is that part of that was the issue with that one?
That wasn't the entire issue, but that was part of it.
Oh, okay. So the question is, how do we get that? When you do that, you have to know what theta is. And so if you take the base vectors and draw them back, you'll get, I'll make them bigger. And one of the things about it, the length of I is the same as the length of J, it's the same as the length of C, and I keep wanting to do E's because that's kind of more standard. Those are all equal to 1, so they're all base vectors. And you have that because you have this. So if you turn around and you just said, I want to focus on UR, it represented in I and J. And then what you find out, that is, at least I write I first, and you are first, and then J second, and you theta. And then this distance, which is sine of theta, J. So that'll give you the ability to, if you got a UR, which is a function of theta, to express it in something that is a function of I and J, which are constants. Always. Then you could do the same thing. Here. That's probably not. Let's make it more. Here. You can do the same thing here. With the U theta. Okay, so if I want to do the x component, I got to go backwards. Minus sine of theta I plus cosine of theta J. Now, if you pay close attention, or if you're comfortable with matrices, you can write it like this. And then you can put I, and you can put a J, and then you can put UR, and you can put U theta. This thing is sometimes called a transformation matrix. Oh, there's the R. And it has an interesting property in that if you turned around and you said, I'd like to find now I'm going beyond this, but if I would like to find, and I'll just deal with the transformation matrix, because if I would like to find a matrix which is, or here, let me do it this way. I'll call this matrix K or T. I'll call it a transformation matrix times, I'll call this, I'll say IJ. I don't know what to call this thing, but this will be the vector IJ. What else could I call it? I don't know. IJ is equal to R theta. So if I take this, slide it over, and multiply times the inverse of the transformation matrix, then what I'll have is that'll come up to be the identity matrix, and this will be transformation of this. In other words, this would be IJ equals to whatever matrix this is times UR and U theta. Interestingly enough, and we can do it, and I can write it down and then show you how, this matrix is simply that. This is a special matrix because
inverse of that is nothing more than the transpose of it. If you want to see this, you can multiply this. You can prove it by saying cosine theta minus sine theta, times that sine theta cosine theta, and then take the transformation and minus sine theta cosine theta. And so you got 4 multiplications to take place. So in this one, you'd get cosine times cosine plus sine times sine. Cosine times cosine, sine times sine. To fill in this dot, you would take this one times that one, which would be minus sine times cosine plus sine times cosine. So that would yield you a 0. And cosine squared plus sine squared, that by nature is always equal to 1. So you take cosine this, that would be minus cosine sine, and sine cosine. So that's going to go to 0. Take this one times that one, this times that. Minus a minus sign is sine squared plus cosine times cosine, and that equals 1. So in fact, it's a bizarre matrix that if you end up in physics, you probably see this more often than in engineering, which is why I threw it in there, is that it's easy. This transformation exists in a lot of different cases, and it can be useful later on in your life. So now, how do you turn this into this? Well, there's 2 ways to do it. One is to go over here and to actually look at the UR and pull it in. Say 4 times, and say, I'm going to cheat now and just say, everywhere I see a cosine, I'm going to put a C. Everywhere I see a sine, I'll put S. This will be minus S. And this will be C. So, CI plus SJ times 4, that's UR plus 3 times sine I plus cosine J. Then you can combine these and you'll get 4 cosine I minus 3 sine I. So you are combining the i's, and I combine the j's. 4 sine 3 cosine. Now, what's interesting here is if you stare at this long enough, you'll realize, wait a minute, if I just multiply, I put in a matrix, and instead of putting the UR or the I's in there, I put the components in here, 4 and 3. And then here is cosine, cosine. Here's a minus sign, here's a sine. So you take that transformation matrix, and you multiply times the components. That's 4 cosine, 3 minus 3 sine, 4 sine, 3 cosine. So you can take the transformation and directly use it on the components. But if you don't want it, and this is something that happens later if you go to grad school, because then they start doing that. So then that's all there is. 4 cosine of theta, whatever that theta is. So that's the other key, is this has to be known. problem it is minus 3 sine of theta, and 4 sine of theta plus 3 cosine of theta, and that's j. So that's how you transform from one to the other. Did that make sense?
Yes, yes.
So what was the other issue with this?
The other issue, very funnily, is something so much simpler than this, something
Oh.
that I shouldn't be having an issue with, I don't really know why.
Oh,
I keep getting the, taking the derivatives of the respective functions.
oh, okay. All right, so tell me the first function.
In this example, the function was, I'll just give it to you in variable form for simplicity.
Oh, yeah, that's a
It
good
was,
idea.
D1, so D sub 1 plus D sub 2 cosine theta.
And this is for R,
Yeah,
right?
this is R of theta.
D1 plus D2 cosine theta?
Yes.
Was it cosine 2 theta, 1 theta?
It was just cosine theta.
Oh, okay. And that's it?
Yes.
Okay.
So presumably, because D1 is constant, when you take the derivative, that term goes to 0, and then
Yeah.
D2 cosine theta should become negative D2 sine theta.
Yeah. So here's your, okay, so this can be tricky, not so tricky in the first one, but in the second one, really bad tricky. And that is, okay, you start here, and then you do this. The problem is, okay, wait a minute, that goes away, you're right. But then, okay, technically, what I would do is break it down to this. And wait until you get a variable by itself, and then say, oh crap, I can't do that, but I can do this. And then you get theta dot, 0 cosine, okay, minus the sign, right? So you get that one. Now that was given, wasn't it? Wasn't that given?
No, I don't think it was. I think they would find it.
Oh,
Yeah, but I mean, that was simple, if I'm not mistaken.
here, let me erase all this, because this is,
It gives us theta in degrees, and then we can just convert that to radians.
yeah, you can, yeah.
And then,
Does it give you theta dot? I hope it does, somehow.
no, I don't think it does, but
Uh-oh.
I was able to get it for myself.
Oh, really?
Yeah.
So what is it? Gosh, I can't remember.
It gives us,
Can I see the problem statement?
Yeah.
Isn't that sad? I made the dang thing, though. Okay, it says
it gives us omega.
okay, that's it, yeah, that's it.
Yeah.
Yeah,
That doesn't,
yeah, so omega is equal to, omega naught is equal to theta dot. And it gave you alpha, right?
yes.
Okay, so that's theta double dot. So, now that's interesting, why did I write it that way versus, I don't know. I don't know why I did it that way versus the other way. The worst part is the next part. This one's not as bad, but if you had other ones, it'd be bad. And that is, if you're looking for R double dot, what you're actually trying to do, take the derivative of all this. The minus sign and the distance can come out. But now you got and this part itself can be broken into this plus that. And this part's easy
because that's just theta double dot, or alpha. And then, this part, you gotta go back and do the same way you did before, and that is, I should have put that in circle around. And that is that you could go in and do the theta, and do theta dt, and that just becomes another theta dot, and then that becomes what, cosine, right? I didn't put if I'd log in if I remember my password, but I don't remember my password. I have it saved on my machine at the house.
Gotcha.
Did that answer the question?
Yeah, I think that more or less answered the question.
I'm kind of surprised I put it in there as omega and alpha.
I mean, I was able to gather that omega was theta dot. I didn't pick up on the fact that alpha was theta double dot.
Yeah, and I guess technically that only shows up in chapter 60, which was the next chapter. Let me see the problem again. I can't believe I did that. Well, I did, didn't I? I should have put a theta dot, I should have put that equals, because that actually technically isn't determined until the next chapter.
I wonder if I'm on the right.
I mean, I don't know. I bet you didn't. I bet there was other people too. So that's on me. So here, since we're doing that streaming thing, I'll make a big point about that. I'll change the color. So in that problem, theta dot is equal to omega. You'll eventually know it anyway. So I mean, that's, what problem was that? What?
That was number 4.
Number 4.
Yeah.
So, sorry about that.
Oh, that's fine.
But the other one is important too, because I think I asked that, didn't I ask that near the end?
Yes, you did. It was the last
Okay.
one.
Because usually that's where most people have the trouble.
Oh, yeah, I had trouble with that too.
Yeah. And so that's, to me, like I'm not going to this time, but I've given a final before, where that's all I do. I come in and I draw it, a vector, and then I come in and do like that, and here's the vector, just like what I did before. Velocity is equal to 3I plus 4J, I'm sorry, UR plus 4 U theta, and what is its components in I and J. And the thing is, the reason I do that, it's conceptual. Many times you're so stuck in the math, you don't see what you're doing. And then when you're outside of this, I even had one where I did this, and tell you how bad I am, I get sneaky like that, where I set it up, and if you recognize it, and then you got UR, and then U theta, right? And then you got this vector that's sitting up here that's like this vector, V is equal to 3UR plus 4U theta. And you stare at it for a minute, and you're thinking to yourself, okay, why did he do this? I need to find this angle. And then you work it all out, and you find out it's a vector pointing perfectly vertical. Because
it's 45 or 45.
yeah, well, that's not necessarily 45, but yeah, the 3-4 is
the same, makes the thing perfectly vertical. So if you bury yourself in the math, you'll take 10, 15, 20 minutes. But if you look at it visually and you say, wait a minute, these angles are this, and if you truly understand what's going on, you're like, oh, that vector length is 5. So the total vector here is 0i plus 5j. And you're done. And so if you visually see and understand it, physically what's going on, you never have to work the math. And you'd be surprised on those finals, how many, I'd say, 10 people in the room, 9 of them will work the math. And of those 9 people, half of them get it wrong. But the one person will say, holy crap, that's basically vertical, and the angles are the same, and that's the answer. And so that's the reason I put those 2 final problems on there. To make you go through the math, but to also make, as you go through it, you visually see what is actually happening with polar coordinates. And so, and then what's funny is, you can have the same vector over here, meaning you can have v is equal to 3ur plus 4u theta. That's not the same thing in ij because it moved. And then another thing you can do is you can take this thing and line it up with the axis. I mean, this is crazy. ur and u theta. And so v will be 3ur plus 4u theta. You look at it, well, crap, that lines up with the x. So that's nothing more than 3i plus, that lines up with the j. This particular moment, and the reason is because theta is equal to 0. And if you go back, you know, that transformation matrix we did a minute ago, remember it was cosine, sine, minus sine, cosine. You put in 0 for the angle, and you get 1, 0, 0, 1. So it transforms exactly the same. So I do that to people on the final, and it causes havoc, but, you know, up until this semester, I'm not trying to cause havoc anymore. I'm just trying to get everybody through as best I can. So did that answer up both the questions?
Yeah, I think it answered that.
What about any of the others?
I felt pretty good on all the, in fact, I think I got all the points on all the others.
Oh, okay.
So I still had a good grade regardless of this, but if I can get 100, I'd prefer it.
Yeah. Now, see, tonight, I'm going to start laying the final. I'm going to start putting the final in there. And then this evening, I'm going to send that grade. Did y'all both get the email?
Yes, I did.
Okay. And so,
I'm not in dynamics, I'm in statics.
oh,
So
there you go.
I'm just sitting in because my next class is here.
Oh, okay.
But I take dynamics next semester anyway.
Oh, okay.
So-
Well, this can be the same thing as this. So in the statics, you got the email, right?
Yes, I did.
Okay.
And I'm working on it.
Okay.
It took me a while to get a scanner that actually worked on my phone.
Oh,
So I have
okay.
them worked out, I just need to get them scanned
Get
in.
in.
to use
Okay.
to get them.
Yeah, and I should have, there was a video, I think, that I did, and I should have done another video describing, there's a thing called, the one I use, there's Cam Scanner,
Mhm.
and then there's another one that's called something else, Doc Scan.
That iPhone, you can scan straight from the iPhone. You have to do it.
Okay.
Yes.
Okay, let me see too.
Built-in scanning function.
Oh, there it is.
Yeah,
Okay.
and it actually works quite well. If you open your Notes app.
Oh, open the note.
Yeah, I know it's very hidden. I like to mess around and look at stuff. And you create a note. I actually have a whole folder dedicated to scanning.
Okay, just create a
Yeah,
new note
just
with that
create
thing.
Yeah, just create a new note.
Okay,
And then you click that camera icon right there.
okay.
And then click scan documents.
Oh,
And then it works the
didn't
same
know
as
that.
any of the other scanners.
And it will save to my notes.
Yeah, it'll save your notes, and then you can save that. If you can keep it in your notes, or you can save that as a PDF to your files.
oh, and it's got the little thing you can move around.
Yeah, it's got this.
Can you do multiple page, like keep scan, and then?
Yeah, and then you can do the next page. So now you would be doing the next page.
Oh, I would be, okay,
And
so,
then when you're done, you just hit save.
Oh, and it tries to line it up too?
Yeah.
Okay. Keep the scan.
And then when you're done, you would just hit the button.
Hit this one. Oh, save right here?
Yeah, right there. It's free, it doesn't have a dumb-looking watermark, and it works just the same.
Okay, so how do I turn it into PDF?
So if you want, you can hold down the scan, just press down on it, and click share.
Oh,
And then if you scroll down, save to files.
oh,
And then you have a built-in files app, and you can create folders and stuff. It works just like files on like a PC would.
oh, okay.
So there's like a folder button right there. I make one just for my files. You can call it files or whatever you want to call it.
I'd make one for class, like one for a status
Oh,
class, one
yeah,
for whatever class,
yeah.
and then I'm like, oh, did I do that? Well, if I don't have it in here, I know I did.
Okay, so under photos, I put it in scanners. Now, how do I get it back out?
You can open the files app. So.
Okay, so you can go over here and open files. Files.
Right. And then you can.
Oh, scanners right
you
there.
can go to that.
Oh, did I not save it? I don't think I
Yeah, you
saved
might
it.
not have saved it.
But still, thank you, though, Paige.
Yeah.
Because that'll make my, I get that done in no time then.
Okay. Oh, I never pushed the save button.
Yeah, don't forget to do that.
Okay, go back to files. Do not throw. I don't know why it named it that way. So now what do I do with it? Is it a PDF?
Yeah, it should save as a PDF.
Okay, so what I'm gonna do is I'm gonna email it to myself. There it is, yeah.
And then I can take it straight from my computer to my.
Oh yeah, it's there from Blackboard to the right.
Okay, let me see if it showed up. Okay.
Time to download a scanner app anyway, but it kinda sorta works, kinda sorta doesn't.
Okay. Alright, so I think I sent it to myself. Maybe I didn't.
Keep learning a lot. Technology.
You know, I have found that the Gmail thing tends to work a little bit better. You know what, that's, okay, so it's sending, finished,
How's static?
done.
It's going, I'm spending a lot of time in different equations. So it's
Sure.
eating up.
Yeah.
But I'm making it through statics.
You have diffy keyword.
Um,
Oh, yeah.
It's, you know,
Diffy
I don't like saying a whole lot for that.
Sure.
Okay, well, that's cool. I didn't know.
I'm making it.
Actually, I guess I probably can find a video out there of somebody who does all this, and then maybe I
Oh, I
can.
bet it's on YouTube by now.
Yeah. If I can find it, I'll post it for the class. But that helps iPhone people, but it doesn't help, you know.
Yeah, Android users are still stuck using apps. As far as I know, maybe they do have a built-in function.
Yeah, maybe.
Give them about 2 months and they'll update with a new one.
Yeah, probably. Android's really, really good about stuff like that.
They stay caught up with Apple.
Yeah.
Because they have a lot less, legality statements.
Yes.
That's one way to say it.
I'm sure it's
Well,
not